Hello everyone. Before we start, I just wanted to ask you for a feedback if the video and the audio is coming fine so that we can go ahead. So if you can please tell me the audio is fine, or if there is any technical issue, we are going to solve it before we start. Thank you. Okay, thank you. Thank you for your feedback. Now we can start. Okay, so welcome to this webinar, Introduction to Grasshopper for Designers, the Power of Parametric 3D Modeling. My name is Marco Traverso. I'm an engineer, designer, and developer. And right now, you maybe are wondering, we have an engineer who is going to speak about parametric CAD for 1 hour. This is not going to be fun. Well, I understand that, and just let me share a short story and a short background story about me and about Grasshopper. So, back in 2002, 2003, I was working as an engineer in a design company where we were designing machinery, turbines, compressor, and I was using Rhino to build 3D models, and I wanted to build them in a parametric way. So I started to write some scripts and assemble them, and then I generalized this concept and came up with a system for creating parametric model inside Rhino. And this is a screenshot that sounds a bit vintage here. And so basically, I even embarked in an ambitious project for a full parametric plugin. I basically wanted to give Rhino users the possibility of having something like this, something like a small SolidWorks or Inventor right within Rhino. Now, around the same time, or a bit later, but there was an architecture student from Delft University in the Netherlands named David Rotten, who was creating beautiful icons and was using Rhino to create stunning architectural presentations. And he was facing the same problem. He wanted to give a way for having a construction history inside Rhino. So he decided to tackle the problem with a different approach. So he basically created the graphic interface, and he called his tool Explicit History. Now, for several reasons, I was never able to finish my own project. David was able to finish his own, and in 2008, Explicit History became Grasshopper. Now, Grasshopper was never able to give designers this, but instead, in the past 10 years, Grasshopper has enabled architects and designers and creators from all over the world to come up with things like this. And this. So I think it's pretty impressive. And in hindsight, I'm really happy that David managed to complete his project and that he's still working on it, because today we have this wonderful tool. And a few years ago, when I went back to Rhino and went back to 3D, I discovered Grasshopper and I started to learn it. And I really fell in love with it, because the designer that's inside me not only sees a visual programming language interface, but it sees a world of opportunities, an exploration of new creative possibilities, the ability to do things that are really hard to do using other approaches. So what I want to do today is to try to convey this message, to give you some possible applications of Grasshopper, some examples, even some small things that maybe can spark some interest, some curiosity in you. So this is my goal for today. So I would like to start just by answering some questions that you may have regarding why Grasshopper. I mean, there are a lot of different tools today, a lot of different 3D applications. So what does Grasshopper do in particular? So I want to touch on some of these things. Now, I want I will be mainly referring to the polygonal modelers like Maya, 3ds Max, Houdini, Blender, because all these programs have some non-destructive tools in their arsenal. So users can basically create some parametric things with it. So where is the difference between Grasshopper and all of these tools? Now, the first difference is related to the structure of the geometry, because the 3D applications, the polygonal modeler, are strongly based on mesh. Their support for NURBS is limited usually. So meshes have some problems when you want to manufacture products, because even if you can create a subdivision mesh which looks very good, then you don't have control over the exact dimensional accuracy, the tolerances, the aesthetic qualities like curvature. And also creating hard surface models using the subdivision surface approach is really tricky, because you have to take into consideration the topology, you have to take into consideration many different things. Grasshopper, on the other hand, being based on Rhino, which is a NURBS modeler, is completely compatible with all the freeform tools that Rhino gives you. But the good thing is that Grasshopper is also compatible with all the meshes, so you can work also with sub-D meshes right inside Grasshopper. So that's a very, very important reason, in my opinion. The other reason is that the tools that are usually put at disposal by these polygonal modelers, with the possible exception of Houdini, which is strongly based on nodes, are usually limited. So if you don't find a deformer or a modifier that suits your need, you have to do something about it. You probably have to script something. So in Grasshopper, not only you have really a high number of different components available, you also have a lot of different plugins and add-ons, and most of them are actually free. So you can choose between thousands and thousands of different tools. But you are also provided with the building blocks to create complete algorithm from scratches, because this is really a visual programming interface. So you can create basically whatever you want. And the interesting thing is that even if Grasshopper gives you the possibility of writing actual scripts with Python and C# and C++ and Rhino script, you have many possibilities. But in my experience, in more than 6 years, it occurred to me maybe a couple of times where I had to resort to write down some code. And this comes from a person who can write some code when needed. And also the approach that you have in Grasshopper with the flow chart made with these blocks is very, very visual. And for a designer or a creative, this means that it does not interrupt your flow. And it's a nice thing to have. So let's go ahead and let's address for a moment the elephant in the room. So I want to just address for a moment Dynamo from Autodesk, because it's actually the main competitor to Grasshopper. Now, what I can say about Dynamo is really nothing, actually, because I don't use it. I've never done it, but I'm planning to do it sometime in the future. But as for now, I really cannot talk about it. So if you have some experience with it, we want to discuss the differences, it would be great, but we'll leave it out from this event. Okay, so let's go ahead. Now we can see that we can do a lot of different things. I'm reporting some images that are from the automotive world, but I think you know that there are similar applications in product design, industrial design. Architecture is full of this. I will be focusing on the design aspects, because regarding architecture, you will find a lot of different informations already available. And regarding design, not only transportation, but more in general, industrial design, product design, I think there are less information available. And I want to share what are, in my opinion, some of the things that make Grasshopper worthwhile, even if you don't do this type of geometry. But you have some good things from using it anyway. So these are examples of a trend that we have today. You may like it, you may not like it, but I mean, for being up to date, having a tool like Grasshopper is going to be helpful. Okay, let's start with the demo actually. So we'll be creating the base geometry for a grill like this. Now, as you can see, this was inspired by one of the concept cars from Mercedes, and but the concept is that we'll be creating an array, a grid of elements that bear some variation along the surface. So this is something that you can easily model with a direct modeling approach, but if you have to modify after the fact, I think you'll run into some problems. So let's open the Rhino window here, and I hope that everything's coming fine. If you have any feedback, please let me know. If I'm going too fast, I mean, I try to have a look at the window here on the right with the chat, so even if I'm alone, I'm trying to do that and trying my best. And if not, I'm going ahead if everything is fine. Okay. So from the registrations that we have received, I saw that there are people who are not familiar with Rhino or Grasshopper. So I just need to make a short introduction, and I will try to balance the information because I want that everyone can have something out of this hour. And so I'm going to present you an overview of Grasshopper, and we'll do the first steps slowly so that you can see the workflow, and then we'll try to speed up and do something more interesting. So let's have a look at the interface here. First thing you notice is that Grasshopper is running on a separate window, and so it can be perceived as a different program, but it's important to understand that if you want to use Grasshopper, since Grasshopper is based on the modeling workflow that you already know if you are a Rhino user, it's very important to understand this workflow. It's very important to have an understanding of how Rhino works and how the geometry in Rhino is structured, because otherwise it's going to be very, very hard to leverage the full potential in Grasshopper. So if you want to learn Grasshopper, I suggest to take into consideration to learn Rhino as well. And the good thing is that Rhino is not that intimidating to new users. It's very, very deep, and it takes literally years to master it. And I still have run into something that I know from time to time after so many years. But for beginners, it's not as intimidating as other software. So, okay, let's start now. We have this essential interface, which has the top menu here, and then we have the heart of Grasshopper. It's this toolbar with the ribbon style structure, and each one of those icons represent a node that we can drag on the canvas, and then we can connect with nodes. Now, all these icons are divided into tabs, and as you can see, each tab represents a different category. So we have parameters like variables, like primitives, numbers. The geometry is here, so we have vectors, points, curves, everything that can contain different type of data. And then we have several ways for inputting numbers or other variables. And then let's move on here, and we have mathematical functions, and we have ways for handling data, vectors, curves, surfaces. I mean, I don't want to go into every single box here. The interesting thing is that all these boxes are expandable, so there are really a lot of different components. We are basically replicating all of the Rhino functionality, and then we add some more. So that's the base. Now, this window here is the canvas. That's where we are going to build our own definition. So we'll be working here mainly. And we'll be keeping an eye on Rhino, because Rhino will serve as a viewport of what is happening inside Grasshopper. So I want to start with the simplest thing that I could came up with, which is a line that connects 2 points. Very interesting. I understand it is going to be very interesting for everyone. But I mean, this will give us the opportunity to understand the base concept without thinking about other things. So the first thing that we need to do is to create 2 points, and then we'll try to find a way for connecting them. So let's start with the point. Now, the point functions are located here under the vector. And by the way, I forgot to tell you that you see a lot of different tabs, but the ones that are from here to the far right come from external plugins. So you don't have to worry about them for now. We will be using only default Grasshopper functions. So we just focus on the first ones. Okay, I was saying we need to construct a point. Under the point box, we can see a point constructor component. So I click on it or I drag it to the canvas. And now we can have a look at our very first Grasshopper component here. So what we have here is a set of inputs that we have on the left and an output on the right. So this is always the case because the flow inside Grasshopper always goes from left to right. The interesting thing is that when I click on it, in the Rhino viewport, as you can see, we have a dot, a green dot here. Now, this is because Rhino is now displaying what is happening inside Grasshopper, and in particular, the component that we have selected. And if I click outside of it, the dot disappears. This is because the inputs, if we hover it, we can see that they have a default values of 0. So that's why what we are seeing is the origin of our system here. Okay, so in order to change the position of the point, we need an input. So in this case, we are going back to the parameter tab, and we are going to use a very important component, which is this slider. The slider is a component that allows us to define a variable, a value for a variable by just sliding this element here. The default range goes from 0 to 1. So if I double click on it, I can set up a different range of values. And in this case, I'm going to go from -10 to 10, just to put in some numbers here. And let's hit OK. So now when we have a value that we want to connect to another component, we can just click on this output, on this small circle, and then we drag this wire up to the input that we have here. And when I move the slider, you can see that, surprisingly, we are moving the point in 3 dimensions. Now we can also connect the same slider, for instance, to the Y component, input of the component here, and we are moving along a line where the X and the Y have the same value. Okay, so now we need another point. In order to do that, I'm going to create it inside Rhino to do something different and to see how Rhino and Grasshopper can interact together. So I'm going to click on this point here, and I'm just created a very simple point inside the Rhino viewport. Now we need to use it inside Grasshopper. The way for doing it is by referencing it from within a parameter, an empty container. So we hit the button here and we click on the canvas. Now we have this empty point, and as you can see, it's displayed in orange. That's why, because it's requiring some kind of input. It's empty at the moment, so we have this warning. Now if we right click on it and go to the set one point function, we can see that the focus now has switched to the Rhino window, and I can just select the point that I've just created. And now when I select the component here, you can see that we have a green dot, and we can also visualize all the components that we have in Grasshopper. So there's a different visualization, different color if the component is selected or not, but in this way we have a clear idea of what's going on. Okay, so now we have the 2 points and we want to connect them. Then we are going to use a line component. Let's see if we find something. We go to the curve tab, and under the primitive, the very first component, it's a line. We are lucky. Well, let's try something different. We don't want our life to be so easy. So let's just use a method that is much faster, and it's going to be what we are going to be using all the time. So I double click on the canvas, or I can hit the spacebar, and then I have this dialog, this search box. So here I can type what I'm looking for. In this case, it's line. So as I type line, you can see that I have all different results. And the second one is the component that, as the tooltip says, creates a line between 2 points. So it looks like the right one. Okay, so now it's in orange because we need to provide some inputs, and now we can connect, as we did before, the first component and then the second point, sorry. And that's the line. So now, if we change the position of the first point by sliding here this input here, or if we move the point inside Rhino using the gumball, in any case, Grasshopper is updating the definition as soon as I leave the gumball here. So this is the visual feedback that makes Grasshopper very interesting when you're building something, because you have access to every single step of your construction. But now let's get rid of this very interesting design here, and let's do something a bit more interesting. So I have prepared a very, very basic surface here, and as you can see, is a NURB surface, and we are going to create that grill that we have seen before just on this surface. So let's stop for a moment, and okay, I see a question here, so I'm going to stop for a moment. Okay, so how do we assign the point that you created to the point bubble again? Okay, so we have the point inside Grasshopper, inside Rhino, excuse me, and then we create an empty variable, an empty parameter in the first tab here. And when we do that, we need to input something here. If we have created the point inside Rhino, we need to use this special function. We right click on it, we go to set one point, and then we have the Rhino command line is asking us to just select the point. So we select it here, and then it's inside Grasshopper. And if we hide it from the Rhino viewport, it's still there because now it's also in the RAM of Grasshopper. I hope it's answering the question. Okay, let's move on. Okay, so when we approach parametric modeling, it's very important to have an idea of how we want to proceed, because the workflow is actually everything. So in this case, we want to create an array of elements arranged on a surface. So we need to create an element, and we need to create a sort of grid of points that will allow us to copy this element on all of these points. So the first thing that we need to do is to reference this surface inside Grasshopper, because right now it's only inside Rhino. So as we did for the point, we are not going to do for the surface. In this case, we need a surface component, and then we right click on it, set one surface, and we are going to select the surface in the Rhino viewport. Now we can also hide the geometry from Rhino so that there is not overlapping and the visualization works fine. Okay, now what do we do with this surface? We need to basically create a grid of points, and there is a component that does just that. And if we double click on it and look for this component, which is divide surface, now we can see that we have to provide three different inputs. The first one is surface. So we need to connect the surface that we have just referenced to this input. Now, as soon as we do that, we can see already a grid of points here. So that's the right solution. The right direction, sorry. For the solution, we need a few more steps, actually. So now what we need to do is to change, if we want, the number of elements. Now, U and V count means that these points are actually created along the isocurves of this surface. Now, every NURB surface as a structure is structured as a parametric surface that goes in two directions, the U and the V. So it's a four-edge surface. If you have a circle, the underlying surface will be still a four-edge surface, but it's trimmed with a circle. And that's why you need a basic understanding of NURBS, because it's very useful when you are creating models inside Grasshopper. Okay, so anyway, it's working, so we can try and input a different number of elements. So I am trying to use a slider here, And this time I need a different range of values, and I will need integer numbers, so I click on this icon here. Let's say that we want to go from a minimum of 2 to a maximum of 20 elements, just to give some numbers. Then I connect this, and as you can see, by sliding this, we are changing the number of columns, in this case, along the U direction. We make a copy of the slider, Ctrl+C, Ctrl+V is a quick way for doing that. We connect it to the second input, and then we can change the number so that we have a more regular grid here. Okay, so now let's focus on creating the base elements. Now, a good way could be to create a rectangle. So we look for a rectangle in the search box by typing rectangle, and the first component is the most basic one. And if I click on it and then move it right here in the, we center actually the visualization so that we can see what's happening here. Okay, so what we are seeing here is a representation of the different inputs and the outputs of this component. So we have this rectangle here, and then we have this grid. This grid represents the plane. This particular component is building a rectangle based on a plane, which in this case is the XY, and then based on the X and Y size. If we over it, we can see that this is expressed as a range. In this case, we go from -1 to 1 for the X and -2 to 2 for the Y. Now, we should provide an interval of values, but Grasshopper is smart enough to know what we want to do. So if I'm going to set a new range of values that go, for instance, from 10 up to, let's say, 100, and I'm going to use just a single decimal digit here, I'm working in millimeters, so I'm trying to use values that make sense in that unit. And as soon as I do that, you can see that the size is updated. We make a copy of this and we use it for the Y size, and you can see that we can now change the size of our rectangle. We are losing the fact that the rectangle is not centered in the plane anymore, but for the purpose of this demonstration it's perfectly fine. Now we also have another component here, which is the radius, that is the fillet radius of the rectangle. We're not going to use for the moment. Okay, so now what we do with this? We need to basically copy this rectangle to this point, to this grid of points. But we don't need only to do that. We also need to orient the rectangle according to a plane that is tangent on this surface. So to find, and we don't need just one plane, but one single plane for each individual point here in the grid. So in order to do that, we need to use a different component that is called evaluate surface. And this will allow to get some properties, local properties of a surface, that is this one. So I'm going to connect to the surface input in correspondence to one of its points. Now in this case, the point has to be expressed in parameters, so the UV coordinate, not the actual 3D coordinates. So we have this particular coordinate system here in the parameters output, and to make things easier, we have a different name here. Can be a little bit deceiving, but the sense I hope the sense comes clear here. Okay, as you can see, we are heading in the right direction. So what we have done here is we have calculated the tangent planes on each one of these points here. So now it looks like we are ready to orient the rectangle. So I'm looking for an orient component, and I found it, and I brought it to the canvas, and now I need to orient the geometry, which is the rectangle, from the source plane, which by default is set to the world XY, so it's fine, we are set for that, and the target plane is going to be this frame output here. When I do that, you can see that the rectangles are arranged just as we wanted to. Now, another thing that we can do here is to create a solid element out of these rectangles here. Now, this is pretty straightforward because we do what we would do inside Rhino. We basically extrude the curves and then we are going to create the caps. So let's look for these components here. So type extrude here, and this is the element that I want to use. I need to provide the base geometry, which is the output of the orientation component. And then I need to provide a direction. And given our system, I'm going to extrude these rectangles along the y-axis towards the negative values. So I double click on the canvas and look for the y-axis, and this is it. Now I need to change its direction, to flip it, and I can use a negative component. I'm trying to speed up because just we have a short time, so I think that the idea can come up clear. Then if you have any question, I'll try to answer, but just to try to show you a number of things here. And then I want to provide a factor, which is the actual extrusion distance. So in this case, I'm going to use another slider, and let's say that we want this distance to range from a minimum of 10 to a maximum of, let's say, 200 again, and then let's set it to somewhere in the middle here. And I also want to reduce the number of decimal digits. Okay, now we connect this to the factor, and then we connect the result of the negative component here in the direction. And as you can see, we have generated all the extrusions in a single shot. Last operation is to cap it. So let's search for a cap operation. Cap holes is the one we are looking for. We are going to connect it, and then we have these boxes. Now we can use a panel here, which is a basic text box that can be used to show what's inside any component here. And this is good for understanding what's going on and troubleshooting things. And when we do that, we can see that this component here contains a list of 45 elements, and they are closed B-reps. Closed B-reps means closed polysurface, means solid. So we made it. And we also can see that this is a list that is structured in groups of 5 elements in this case. And they are basically the 5 elements that are along the V direction here. Now, I want to just stop for a moment and make a couple of observations. As you can see, single components in Grasshopper are able to work instantly on multiple data. And I think this is one of the crucial factors that make Grasshopper very effective when working with this type of geometry. Because if you think about that, even if you want to write a script that creates this grid in a very automatic way, and it's quite easy actually, but you have to basically write down some cycles, some 4 next statements that cycles through the different elements. It's very basic, but it's time consuming. Here, the Grasshopper components are smart enough to understand, for the most part, what you're looking for. It's important that the structure of the data, the list that you see here, is consistent. And that is an area where you can really get into some problems when you go to very advanced things. But as you can see, for something quite basic, most of the time it works, it just works. One last thing before we go to showcase other things is that I want to introduce a variation. As we saw in the picture, we wanted to have a variation for these elements that depends on the position on the grid. One way for doing that is using a point attractor. This means that we basically are going to change the properties in this case. We are going to scale these individual elements depending on the distance from a given point. So I want to create a point inside Rhino as we did before, and then I want to use it inside Grasshopper. So again, I'm creating a point component here, set one point, select the point inside Rhino, and the orange dot means that we can use it inside Grasshopper. Now we need to calculate the distance between this point and all these elements. So we need another point for each one of these elements. And if we think about it, our very first component, the divide surface, among its outputs had just the physical 3D points, the coordinates of the points that are displayed here in green. So what I can do is to basically connect the output of that component to nothing, because I need a distance component first. So let's double click on the canvas and look for a distance component. Okay, luckily enough it's here, so now we can connect the 2 points. So I'm going to connect the points here and the other point that we have defined inside Rhino. And now if we connect this distance to the panel, we can see that we have basically created a list of numbers. These numbers are the distances between each one of those points and each one and this single point here. So again, a single component, and in this case we have 45 variables. Now we can see that the value goes up to around 600. So I'm going to divide this value for 600 so that I can use it as a scaling factor. So I'm going to type divide, and then I'm going to type 600 right here in the search box. And what happens is that now I have a division component where the second input is already set to 600. So it's a nice shortcut to have. When I connect this, I now want to see what's inside here, and you can see that we have values that are compatible with the scaling operation. So now we need to scale those elements, and we can type scale in the search box and use the very first scale component that we have. This is a global scale. We are not worrying about non-uniform scale right now. So we need to provide a geometry, so we can provide this. And as you can see, something is happening here. It's scaling the entire geometry starting from a center that is set to the origin. We don't want that. And it's also using a default value of 0.5. Now, if we connect, we need multiple centers actually, because each one of these elements needs to be scaled from its origin or from a point that is strictly related to it. So we can use the same points that we have used to calculate the distance. So this outputs here, and I'm going to drag the wire here. Okay. And what we see, if I scale this thing here, is that each element has been scaled by a factor of 0.5 in the correct way. Now let's try and see what happens when we provide these values here. And now, as you can see, what we have is a nice variation, and as I move the point inside Rhino, everything is updated inside Grasshopper. So now comes the fun part, because now I can experiment with different numbers of elements, with different position for my point, and that's the biggest part of the problem is solved. One thing that we can have for free here is to basically use this fillet radius. Now let's see what happens if we use a slider and we go from let's say 0 up to 50. Okay, let me select this so that okay, okay, here we are. And when I move this slider, and I want to zoom on these elements here, because when I move the slider, what happens is that we are creating solid fillets instantly. This is a modular dream, actually. So this means that we are able to implement some interesting features by adopting a correct workflow. In this case, we had to create these fillets on the profile curves and not on the final solid. So if we want to have this very fast response here, we need to have something that is can be calculated very, very fast. Okay, I think this is clear, the direction. So I want to show you a couple of steps that can move on this definition. So I have them right here. So what I did here was to basically add something. Let's see if this is working. Okay, see. Okay. So we have our grid of elements with the fillets, and then I created basically a little frame here. And as you can see, I did it using two curves. And let me deselect this. I extracted the edges and created an arc, and then used the sweep to rails function. Sorry, maybe I'm too fast here, to create these frames. So we get rid of that ugly sharp corner, and we have something nicer to render. Another thing that we can do is basically to use our, and I'm going to select this other definition here. We can use the ISO curves of our surface and a section that we define as a rounded rectangle here to basically create some vertical beams, some vertical structural members, so that these elements are not just floating in the air. And we can do that the same thing along the U direction. And so let's stop right here and let's see what are we doing with all of this stuff. So if I select all these elements, now let's say that I want to render it because I have a webinar and I'm running out of time, for instance, something like that. Now what I can do is to use the bake function. The bake function is quite satisfying because you basically open this radial menu and hit this egg icon, and what happens is that you have nothing here because there was a command acting inside Rhino, but when I do that, it thinks a little bit about it and then creates all the geometry right inside Rhino. Now it took a few seconds just because it needed to create the render mesh for visualization. The geometry was already there. And now what we have here has nothing to do with this definition here inside Grasshopper. So if we change parameters now, this is not going to change. And this is a quick way for finding something that we like, save it to Rhino and just render it, or save it as a file. Now, we can also save this parametric definition, and we can also save different solutions using here the save state command. So we can have different snapshots of parameters. Okay, so before I switch to a couple of other examples, let's see if anyone has a question. I read a couple of questions that I don't know if there will be time to answer. I can go a little bit beyond the 1 hour time, but I make sure to answer every question in case on YouTube on the comments or replying by email. So okay, I'm moving on right now, and let's go back to our presentation here and see. Yeah, this is not a tutorial, obviously. I should have said this before, but I think it's pretty clear that it was a simple demonstration. Now let's move on to the wheel example here. So this is a turbine wheel, the so-called turbine wheel, and I tried to create something that could quickly give us some kind of similar result here. And this is it. And no, it's not like this. We have to change some parameters to get there, but it can be done. So what we have here is a definition that is structured in different blocks. Now it can be a bit intimidating, but we basically need to think with a modular approach here. And this definition is actually using different blocks to also create the tire, the tread, and the outer rim. And I don't want to focus on those because this is a pretty obvious application. It's a parametric model, so we can have our outer rim model just starting from the technical parameters, the outer diameter, the thickness, the fillets, and we can scale it in the proper way without losing other properties. But let's focus on just the spokes, which are the core of this design. So in this case, these spokes are created by having a single section here, and I'm going to just hide them for a moment. And as you can see, we basically are creating a set of different sections here, and then we are going to loft them. We are going to have some control over the section and over the position and the rotation of the other sections here. So let's see what we have here. So let's enable the preview of the spokes, and let's see, let's also hide the tire here. Now, when we go here, we are able to change the size along one axis or along the other. We are able to change the position of an intermediate control point so that we can have some form of concavity or convexity here. And that's true even, even behind the spoke. And then we can change, in this case, we have two blend curves that connect two edges. And when we do that, we are changing basically the geometry. We can go from a very sharp edge like this to a very soft edge like this. Okay, so now let's try to change what's happening inside the spine that defines the spoke. So let's go here, and as you can see, we have a set of different parameters, and for each parameter we can set the initial value that is in correspondence of the hub and the final value that is correspondence of the outer rim. So when we, for instance, change the radial angle, we change the rotation of the starting section, and the same happens for the final value here. So we can have this spiral shape. For the twist angle, the same thing. And then we can also change the scale, the starting scale factor or the final scale factor. This is going to control the Y, which is the thickness in this case, and then we can also control the offset so that we are basically controlling how these spokes are intersecting with the outer rim and with the hub. Now, a very satisfying thing to do here now is to change the number of spokes here. Now, the interface that you see here is basically replicating a selection of parameters here are just copied here, and that it can be handy sometimes. Now, when we increase the number of spokes, we are basically finding something that resembles a turbine wheel. We can play with the values. We can also change the variation curves of all of these elements here. And what we end up having is this thing here. And as you can see in this case, I also included the solid fillets. Everything is done within Grasshopper, so the Boolean union and everything. It takes a bit of time, but we are speaking about 1 minute maybe in the worst case. And so if you know that it's going to work and you know that you want that model, 1 minute, I think it's quite reasonable. And this is something that shows how that definition can be used to have different concepts. And I want to touch on this by showing also this picture. Basically, I wanted to challenge myself to start from the most boring thing that I could think of, a bottle with just a simple optional set of cut lines. And by changing just a bunch of parameters, okay, I got some questions. the webinar is going to be available on demand. It's going to be posted on our YouTube channel. So unless there is some technical problems that's out beyond our control, you can watch it later, maybe at a slower speed. I'm sorry about that. Unfortunately, the audience is quite varied, so yeah, I'm trying my best to do something that balances things. So anyway, it will be available. Okay, now this is not something amazing in terms of design, but to me this proved how even a very basic thing can be turned into something different. And all of these elements, all of these ideas, I would have never had them if it was not for this. And I created more than 20 of them in under an hour. So that is something quite nice to have. Okay, I want to go ahead and just show you a last thing, because we are running out of time actually. So I want to show you just another definition. This is quite different, but it can apply to many cases in transportation, interior design, and product design also sometimes. So in this case, what we have is something that allows us to create stitching. Now what we are doing here, we are using these surfaces, we are extracting curves from them. So these are isocurves of the surfaces, and then we are using a couple of blocks that contain different elements to basically create our final stitches. Sorry about that. We have some problem of visualization sometimes. With Grasshopper, there's something going on with the meshes sometimes. So what I want to show you is the final result here. So we basically have these stitches that we can control in many different ways, and we can basically change the shape and the curves in real time. And I want to show you this, if this thing is not dying on me. Okay, so here we have our base curves here, and we can go ahead and basically create a pipe around it. And this is going to be very useful for visualization. In this case, meshes are perfectly fine. Now, these artifacts actually go away when you bake it, so it's not a problem of the definition. And we can also do something a little bit different, which is basically create threads for the stitches. And what happens is that we have a complex geometry here that is made up of single threads. So the final result is that we can update the solution in real time just by moving the surfaces here, or we can also try something to move the control points, and the definition is going to be updated with the new shape here. It's taken a while because it's creating all that complex meshes. So this is quite useful if you want to quickly create a stitch. I mean, you can use image texture, but that's not going to be quite easy as this, because you have to project and use UV mapping and so on. So let's go back to our thing, and this is a type of pattern that many people asked me about, and I will be covering it in an upcoming video. This is the same pattern that is applied to a shape, an arbitrary shape. And then a very quick summary of this. We can handle complex shapes. You have seen how the components are designed to handle multiple data. We can fine-tune our design. Imagine you can try different fillets, different details, different curvatures. This can be done at a global level if you have complete parametric model, but you can also do that on a single element of a model that's already there, that you have done in a different software. This means that you are able to create design iteration quickly, saving time, saving energy. And this means that this also can speed up the decision process within meetings, because you can just avoid the back and forth between different solutions, and you can just use this as an interactive tool within a design team to understand if it's possible to have a compromise right there on the spot without making things that can literally take days in some time. So I think that the investment is really, really worthwhile. And then we have workflow automation. It's a complete programming language, so we can create macros, we can automate many things, and I'll be creating new tutorials and new webinars that demonstrate specific applications. And lastly, we have these creative explorations, which it's not the most important factor, but it's a very interesting one, and it's also quite nice because it comes for free, basically. You play with the parameters once you have a model, and then you are done. You can find new shapes that you may like. Okay, I want to introduce with this webinar a brand new activity that we are starting right now. So we are going to offer through the Parametric Project website and through my own website services to companies, to designers, to design studios that include custom training that is completely focused on the different workflows, because we understand that every designer, every design department has a different way of doing things and deals with a different kind of products, so the workflow is different. So it's important, I think, to provide the training that's basically specifically created for that specific workflow. And similarly, we want to offer the development of custom solutions so that you are able to integrate this type of possibilities right in your own existing pipeline without having to change things. And this is something that we are going to offer on-site and off-site for the training and for the development. And we also going to offer it as individual training with online sessions. Now we are going to do a lot of things in the coming weeks and months about this. So what I want to tell you is if you are interested in these things and you was interested by this glimpse that we had here today, then you can go to this website. Parametricproject.net is going to be online. Right now there is only a contact form, but it's going to be online within the end of the year. For now, you can go to my personal website where there is already material, and especially if you have any inquiry, if you have any interest, any question, if you wonder how you can implement some of those solutions, or you are interested in having some custom training for that, then by no means reach out to these email addresses or with the contact forms or with the usual suspects, whatever works best for you. Okay, the question and answers. I would like to know if there is anyone who can stay 5 minutes longer, because I'll try to answer some of the things that some of the questions that I see in the chat here. So okay, I see a lot of questions that require a bit of time. So I'm going to answer just one single question that I received by email, and then I'm going to answer each question that you posted directly on YouTube in the next day. So I got a question regarding Rhino, Rhino for Mac and Grasshopper for Mac. So I wanted just to say that Grasshopper for Mac is already there, is functional, can be used. Currently has some limitations in regards to support for plugins and some features, but McNeil is working to have the two versions equally featured. And if you want to know more, the best advice that I can give you is to just try the trial versions for both the Windows and the Mac versions. You have 90 days, so 3 months for each version, and all the questions about the product can be done through the official website rhino3d.com. And I've been knowing the McNeil team for 15 years now, so what I can say is that you cannot go wrong with them. They're great at what they do, so by no means go ahead and contact them to have more information. Okay, I really wish to thank you because this was a very first webinar live event for us and for me, and I would really appreciate if you have some feedback. I really hope that you got some interesting information or idea or just some curiosity here was sparked in you by this presentation. And again, feel free to reach out, and if you want to know more, if you want to be notified, if you subscribe to this webinar, you are already subscribed to a mailing list. If you want to stay subscribed, you will get notification only when we have something meaningful. We won't send you any spam here. And if you are not subscribed and you want to receive the ebook regarding other reasons for using Grasshopper, then I'll post a link shortly for the mailing list, and you can follow this YouTube channel or my personal YouTube channel, my personal website, I mean the usual suspects. So if you want to know more, I think there will be many content about this in the coming weeks and months. So if you have any feedback, that's the best way for me to improve, to provide better values. So I would really appreciate it. And in the meantime, thank you again. And until the next time, you have a great day, everybody.